Okay, we're about to connect two ideas that feel like they belong in totally different realities: the strange, almost magical math of quantum physics and the very real problem of AI that, well, you just can't trust. What if the solution to making AI truthful was hiding in a physics crisis from 100 years ago? Let's dive in. So, on one hand, you've got the birth of quantum mechanics, these equations that perfectly predicted reality but seem to be written in some kind of alien language. And on the other hand, you have today's AI, this brilliant speed reader that's trapped in a box, confidently just making stuff up. You see the parallel? One field was struggling to understand reality, the other is completely cut off from it. And this leads us to a really wild question. Is there some secret connection between the math of the quantum world and the errors we keep seeing in AI? Unbelievably, the answer seems to be yes, and it could change everything we think about machine intelligence. To find that link, we have to go all the way back to the beginning, back to quantum physics and a number that physicists honestly thought was pure fiction. This quote right here, it captures a moment of pure philosophical panic. It's 1926, or when Schrödinger writes the master equation for quantum mechanics, but there's a ghost in the machine, the square root of -1, this so-called imaginary number. This horrified thinkers like Niels Bohr. I mean, if reality itself was based on a mathematical fantasy, was physics even real anymore? But here's the twist. Imaginary numbers aren't imaginary at all. They're the language of rotation. Just think about it. Real numbers describe moving along a line, forward and backward. But complex numbers, which mix real and imaginary parts, they describe rotation. They're absolutely essential for understanding anything that involves waves or cycles or phase. And you can think of it like this. The imaginary number I is the rotation. It's the act of spinning itself. Pi, its more famous cousin, just describes the scope of that rotation, kind of like the distance around the track. So one is the motion, the other is the measure. You need both. And here is the crucial point. In quantum mechanics, these numbers are not some kind of trick. They're fundamental. You literally can't remove them without breaking reality. They let waves interfere. They make sure probabilities always add up to 100%. And this leads to a pretty radical idea. What if reality, at its very core, is just things evolving through rotation? Okay, so let's just hold that thought about rotation and reality for a second and pivot to our second mystery, AI. Why do large language models, LLMs, get things so confidently, spectacularly wrong? This image just nails the problem, doesn't it? Think of a current AI as a genius who's read every book ever written, but has been trapped in a windowless room its entire life. It knows the word apple usually shows up near red and tree, but it has never seen or touched or tasted a real apple. It's a master of statistics with zero connection to the real world. And this leads to a pretty stunning conclusion. AI hallucinations. They're not bugs that we can just patch out. They are a mathematical certainty. Imagine trying to perfectly wrap a crumpled up map of the world around a smooth globe without getting any wrinkles or tears. Well, Gauss's theorem proves it's impossible. In the exact same way, you can't force an AI's complex web of word guesses to fit the clean, simple rules of reality without creating these tears. And we call those tears hallucinations. So, we've got two huge problems: a quantum world that seems to be built on imaginary math, and an AI world that's totally unmoored from reality. Let's get to the proposed solution, which starts to tie these two threads together. This brings us to the absolute core idea. What if we've been thinking about meaning completely backwards? What if a concept like apple wasn't just a word connected to other words, but a precise, universal address in a mathematical landscape? A number that anyone or any AI could just calculate and find. Now, the proposed solution is a brand new building block for meaning, and it's called a token. You can think of it like a digital atom of truth, a single, unforgeable unit. And the blueprint for it? It's not actually new. It comes from a 150-year-old idea from a philosopher named Charles Sanders Peirce. So how do you turn that philosophy into code? Well, Peirce said every sign has three parts. First, the sign itself. Here, that becomes a unique digital ID. Second, the real-world thing it points to. That becomes a verified measurement, like a reading from a sensor. And third, the sign's history. That becomes a secure, unchangeable log, kind of like a blockchain. So you get an ID, a fact, and a history, all locked together. And here is the most mind-bending part of this whole thing. That digital ID, it isn't something we just invent. It's calculated using a cryptographic function, the same kind that secures your bank account. This means the address for a concept like water isn't a word, it's a fixed mathematical fact, just like pi. Anyone, anywhere on Earth can calculate it and get the exact same number. Suddenly, meaning stops being a guess and becomes a discoverable coordinate. Now, building an AI on this foundation of discoverable, verifiable meaning, it has profound consequences. It creates an entirely new kind of physics for information. This is where it all comes together in a concept called semantic gravity. The idea is that every single time a token is verified with a real-world measurement, it's like placing a heavy object in space-time. These verified facts literally curve the AI's semantic space-time, and that makes truth the path of least resistance. So just like gravity tells planets how to move, this semantic gravity tells meaning how to flow. And the direct result of that? For an AI built this way, telling the truth is computationally cheap, and lying is incredibly expensive. A hallucination would mean fighting against the cumulative weight of every verified fact in the system. It'd be like trying to roll a giant boulder uphill against gravity. It becomes a mathematical and energetic impossibility. This table really just summarizes the massive shift. Instead of guessing the next word, this new kind of AI predicts it based on verified facts. Instead of having no memory, it has a permanent, unchangeable history. And instead of safety being some filter you bolt on afterwards, it's baked right into the structure from the very beginning. It's really the difference between a house of cards and a fortress built out of stone. We started with quantum physics, where a strange imaginary number turned out to be the key to understanding rotation and reality itself. We end with an AI where meaning isn't a guess, but a verifiable mathematical fact. The final takeaway here is pretty powerful. Maybe the race for true AI won't be one with more and more data, but with a better equation, one that finally anchors information to the real world.